So welcome back to RS Academy. This is Ravi Shankar sir, chemistry. So we are discussing class 10 basics. That one basic one completed, that is elements and symbols. And basic point 2 I would like to explain, that is electronic configuration. So get ready my dears. So take out a book and pen and please note it down all the points what I am going to write on the board. Right. So today basic topic number 2, that is basic topic number 2, it is electronic configuration. Electronic configuration. Electronic configuration. Electronic configuration. So electronic configuration, the basic topics of chemistry. Without electronic configuration, we are unable to understand chemical behavior of the elements. And if you want to write chemical formula, and if you want to write equations, so these all we require and electronic configuration. Not only that, if you want to know the location of the elements in a periodic table, you must have the electronic configuration. Right. So electronic configuration. So what is meant by electronic configuration? So I would like to explain the electronic configuration with the help of very simple example. Let us discuss about birthday. What is meant by birthday? What is meant by birthday? So you must have know that what is meant by birthday. I know that, right? So, but according to so many of the students, birthday is nothing but distribution of distribution of chocolates in the class. What is meant by birthday according to students nowadays? Distribution of distribution of distribution of distribution of chocolates chocolates distribution of chocolates to students in class. So this is the definition according to students nowadays regarding to birthday. So distribution of chocolates to students in the class is called birthday. If you want to distribute the chocolates or if you want to celebrate the birthday, we require 3 points. Point number 1, we need chocolate box with number of chocolates. Chocolate box with number of chocolate box. Chocolate box with number of chocolates. Next, point number 2. Point number 2, list of the students. List of the students. Point number 3, order of the students. Order of the students. So if you want to celebrate your birthday in the class, we must have follow these, or you must have required these 3 points. Point number 1, chocolate box with number of chocolates. Point number 2, list of the students. Point number 3, order of the students. For example, chocolate box. We have to know how many chocolates are there. We have to know, and we require one box of chocolate to distribute in the class. Point number 1 completed. Next one, list of the students. So let us assume the birthday of X. Let us assume X going to celebrate her birthday. So she required these all the points: chocolate box and list of the students. She has prepared one list before the distribution of chocolates in the class. So that is the list is, let me write. So first one, those names are started with letter S. She would like to give 2 chocolates. For example, name of the student Sri Lakshmi. Let us assume. Next one, Swati. So I would like to take only 2 examples. So listen to me. So Sri Lakshmi is the name is started with S and Swati name started with S. So X decide to give two chocolates to the students. Those names started with letter S. Next one, she had prepared one more list based on the letter P. Based on letter P, she would like to give, for example, Pavan. Next one, Prasad. For these two fellows, she is ready to give six chocolates. Six chocolates. Next one. So based on letter D, for example, Dhanush. Dhanya, let us assume. She would like to give 10 chocolates for the students. Those names started with letter D. And last letter is F. She decided, F means friends. She would like to give 14 chocolates. So this is a list of the students prepared by X for distribution of chocolates regarding her birthday in the classroom. Listen carefully. So this is a one basic example to understand what is the actual electronic configuration. Please note that is everything. It's not a it's a very good example to understand what is electronic configuration. Please note down each and every point what I have written on the board. So birthday means distribution of chocolates to the students in the class. To celebrate birthday, we require 3 points. Point number one, box chocolates box with number of chocolates. List of the students. Those names started with S. Two chocolates started with P. Six chocolates. D. 10 chocolates. F is nothing but French for 14 chocolates. Order of the students. Order of the students means we should follow right side or left side order. We should follow in order to distribute the chocolates in the classroom. We should follow the particular order. Right? Please try to understand these all the points. Now I am going to compare these all the points with electronic configuration. Get ready, students. So 3 points we required: chocolate box with number of chocolates, the list of the students, and order of the students. So now let us enter into the actual topic, that is electronic configuration. I am going to compare this one with electronic configuration. Get ready. Right. Right. Let me give one point before going on start electronic configuration. You must have know that atom has pin. Atom has pin. Atom has pen. Pen means proton, electrons, and neutrons. So each and every atom is made up of three fundamental particles like proton, electron, and neutron. You must have know that all the protons and neutrons are located. Center of the atom is called nucleus. All the negatively charged particles are revolving around the nucleus in a fixed circular path. These are called shells or orbits. Shells or orbits. Atom has proton, neutron, and electron, and all the protons and neutrons are located center of the atom is called nucleus, and these particles are called nucleons. Negatively charged particles are revolving around the nucleus in a fixed circular path. These are called shells or orbits. So if you want to know the location of proton and neutrons, it's a very easy to, because of these are located in the nucleus. And what about the location of electrons? You must have know that electrons are revolving around the nucleus in a fixed circular path. These are called shells or orbits. Infinite number of orbits are there around the nucleus in an atom. So that's why we have to know the what is the location of the electrons in particular shells. How many shells are there in the atom? For each shell, how many electrons are there? So this is called electronic configuration. So please note it down, definition for electronic configuration. So now let us compare this one with birthday definition. Birthday means distribution of chocolates to the students in the class. Then what is meant by electronic configuration? Note it down. Electronic configuration means distribution of distribution of electrons distribution of electrons to the orbitals to the orbitals to the orbitals in various or different shells of an atom. Different shells of different shells of an atom. Different shells of an atom. The distribution of electrons to the orbitals in different shells of an atom. So body means distribution of chocolates to the students in the class, or simple way, the distribution of electrons to the shells in an atom is called electronic configuration, right? So to celebrate the birthday, we require 3 points. I said already, chocolate box, so list of the students and order of the students. In a similar way, to write electronic configuration, we require 3 points. Write down points one by one. Point number 1. Atomic number we have to know. Atomic number. Point number 1. Write down atomic number. Atomic number. Atomic number. Atomic number. So symbol of an element can be represented with capital X, and so Z is atomic number. A represents atomic mass. In this one, this is a symbol of element. Symbol of element. This one is atomic number. This one is atomic number. This one is mass number. This one is mass number. Right? So we require atomic number. So what is meant by atomic number? Write down. Atomic number is represented with capital Z. It tells us number of protons or number of electrons present in neutral atom. So according to Dalton atomic theory, so atom on the whole is electrically neutral. That means number of electrons are equal to number of protons. Number of negatively charged particles are equal to number of positively charged particles in an atom. That means atom on the whole is electrically neutral. So that's why atomic number is actually number of protons present in the atom. But in an atom, number of electrons are equal to number of protons. So that's why atomic number is represented with capital Z. It tells us number of protons or number of electrons present in the atom. So we require atomic number because of we need to distribute the electrons in an atom. If you want to distribute the chocolates, you require chocolate box. In a similar way, if you want to distribute the electrons in an atom, we must have know the atomic number because of atomic number tells us number of protons or number of electrons present in an atom. So atomic number Z equals number of protons or number of electrons. Next one, atomic mass number. No need here, but I would like to give what is atomic number, atomic mass number, right? Atomic mass number represented with capital A. It tells us sum of the protons and neutrons present in the nucleus. Sum of the protons and neutrons present in the nucleus. For example, I will give later on. So listen to me. Next, from this one, number of neutrons equals, you will get A minus Z. Please remember these all the formulas. Atomic number is represented with capital Z. It tells us the number of protons or number of electrons present in an atom. Atomic number A represented with capital A. Atomic mass number is represented with capital A. It gives sum of the protons and neutrons in an atom. So to find out number of neutrons, A minus Z. Okay, right. For example, sodium atomic number 11, mass number 23. That means each sodium consists of 11 electrons, 11 protons, and 23 minus 11, that is 22 electrons. Sorry, 12 electrons. 12 neutrons. 12 neutrons. Okay, right. So this is what is meant by atomic number. If you want to write electronic configuration, we have to know atomic number. I said 1 to 30 elements, symbols and atomic numbers in basic class number 1. Please go through that, then you will get what are the atomic numbers of 1 to 30 elements. Please learn 1 to 30 elements, symbols and the atomic numbers, right? So this is a point number 1, required atomic number. Is it clear to you? Right. Now let us move on to point number 2. Point number 2. List of the students. In case of birthday, list of the students. In case of electronic configuration, we require list of subcells. List of subcells. So put it in second point. List of subcells. List of subcells. Right. You must have known that all the protons or neutrons located at center of the atom is called nucleus, and all the electrons are revolving around the nucleus in a fixed circular path. These are called stellar orbits or shells. So each shell is divided into subcells. Subcells consist of orbitals. So electron is located in the orbitals. Okay. So what is the subcells and what is orbitals we will get in higher classes, and later on forthcoming videos I will explain in detail. But here I would like to give what is electronic configuration in simple way. So that's why I would like to minimize this introduction, right? So subcells. Shells consist of subcells. Subcells consist of orbitals. How many shells are there? How many subcells are there? I am going to write. Please write down. Right. First shell. First shell also represented with capital K. It has only one subshell, that is S subshell. Has only one orbital, that is S orbital. In S orbital is represented with square box. The maximum capacity of S orbital is 2 electrons. We should fill only 2 electrons in S orbital. Right? Second shell is represented with capital L. So it has two subshells, that is S and P. S subshell has only one S orbital with filling capacity 2 electrons. P subshell is divided into 3 orbitals, that is 3 p orbitals, capacity 6 electrons. I said in case of birthday, so list of the student, those names started with letter S, only 2 chocolates. Those orbitals has S orbital. In case of S orbital, we should fill only 2 electrons. In case of P subshell, we should fill 6 electrons. Please keep that point in your mind. Right? Next one, third shell, represented with M. It has 3 subshells, S, P, D. S again, one box with 2 electrons capacity. P, 3 boxes with 6 electrons capacity. D, 5 boxes. Boxes are nothing but orbitals. 1, 2, 3, 4 and 5 with 10 electrons capacity. Right? Next one. So please copy this one. I need a space. Right. Now I will write fourth shell. Fourth shell. Fourth shell, that is nth shell. Fourth shell, nth shell. It has 4 subshell, S, P, D and F. S subshell with only one box with 2 electrons capacity. P subshell with 3 boxes with 6 electrons capacity. So in case of D, 5 boxes, 1, 2, 3, 4, 5, 10 electrons capacity. F with 7 boxes, 1, 2, 3, 4, 5, 6, 7 with 14 electrons capacity. Okay, please remember these. So 4 shells, nearly 4 shells are there. Infinite shells are there, but we have to know up to 4th shell, right? 4 shells are there. First shell has only one subshell, that is S, and has only one orbital. Second shell, two subshells. Third shell, three subshells. Fourth shell with four subshells, S, P, D, F. But if it is difficult to remember, just remember one thing, that is, in case of S, we need to fill 2 electrons. In case of P, we need to fill 6 electrons. In case of D, we need to fill 10 electrons. In case of F, we need to fill 14 electrons. Please remember this one. Okay, this is a point number 2. Point number 1, atomic number. Point number 2, list of subshells. Now, so let us move on to third point, order of orbitals. Order of orbitals, or you can say order of subshells, right? Order of orbitals, right? So to know the order of orbitals, most of the students are used the Euler diagram, but I would like to give one simple keyword to remember order of the orbitals in simple way. So please make use of this one. Right? Star star, power star, daring power star, dashing power star, full daring power star, full dashing power star. So this is a simple keyword to remember order of the orbitals in simple way. Please remember that. Star star, power star, daring power star, dashing power star, full daring power star, full dashing power star. Right. S orbitals, S subset started with first shell onwards. So we should give number 1 to S. S, 1S, 2S, 3S, 4S, 5S, 6S, 7S, 8S. Please follow this pattern. Next one, P started with second shell onwards. 2P, 3P, 4P, 5P, 6P, 7P. D started with third shell onwards. So 3D, 4D, 5D, 6D. F started with fourth shell onwards. 4F, 5F. So please remember this pattern. Practice 2 or 3 times, then you will get clear picture. So star star, power star, daring power star, dashing power star, full daring power star, full dashing power star. Right. So this is the order of the students, or nothing but order of the subshells. Right. So to write electronic configuration, we require 3 points. Point number 1, atomic number. Point number 2, capacity of the subshells. Point number 3, order of the subshells. Right. So now let us write electronic configuration for one element. Let us take iron. Listen to me. Iron atomic number 26. What is electronic configuration? Distribution of electrons in various shells of an atom. So according to their increasing energy order, we need to fill the electrons in the subshells. This is given by Aufbau principle. According to Aufbau principle, we need to fill the electrons in orbitals. So those orbitals are having lowest energy, they must get electrons first. So we need to fill the electrons from these onwards according to Aufbau rule. So let us fill the electrons. So iron has 26 electrons. We need to distribute 26 electrons in these orbitals, right? So S capacity 2 electrons, right? 1 S2, again S 2 S2, 2P6, 3S2, 3P6, 4S2. Up to this 20 electrons completed, remaining 6 because of atomic number of iron 26. So 10 and 10, 20 completed. So next one, remaining electrons we need to place in D. Even though D capacity 10, we have only 6 electrons. So that's why we need to keep the 6 electrons in case of D. So let me write here, iron electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, sorry, 3p6, S3p6, 4s2, 3d6. So this is the electronic configuration of iron. So this is a few words regarding to electronic configuration. Electronic configuration means distribution of electrons in various shells of an atom is called electronic configuration. To write electronic configuration, we require 3 points. Point number 1, atomic number. Point number 2, list of the orbitals, that means capacity of the orbitals or subshells, and point number 3, order of the orbitals. If you know these 3 points, then you will get clear picture how to write electronic configuration. And I would like to write these 3 points again on the board. Please copy that. 3 points were required. I would like to write these points in short form, then you will get clear picture. So to write electronic configuration required atomic number, that is Z. Point number 2, capacity of the subshell S 2 electrons, P with 6 electrons, D with 10 electrons, F with 14 electrons. Right? Next 3 means order of orbitals. Order. I said order. So please remember that order. It's very easy to remember and it's very easy to write electronic configuration with that keyword. Right. So now let us write few more examples. Let us write electronic configuration for few more elements. Look into that. Let us take sodium. Sodium atomic number 11. Electronic configuration 1s2, 2s2, 2p6, 3s1. This is electronic configuration of sodium. That means in each sodium atom, 1 means first shell, 2s2 means second shell, 3 means third shell. That means each sodium consists of 3 shells. Each sodium atom consists of 3 shells. First shell with 2 electrons, second shell with 8 electrons, third shell with only 1 electron. So this is the distribution of electronic configuration. So this is the distribution of electrons. Distribution of electrons in various shells of an atom is called electronic configuration. That means electronic configuration gives us how many shells are there in the particular atom and for each shell how many electrons are there. So this is called electronic configuration. I hope you understand. So please follow these all and keep learning. Have a nice day. Take care.